Okay, guys, so we are going to talk about solving rational equations and radical equations in this lecture. The first thing we're going to talk about is how to solve a rational equation, and I'm going to do a bunch of examples for you, which I love to do, so hopefully you'll have a good time as well. But what is a rational equation? So what's a rational expression or even a rational number? If you look at the name or the word rational, notice there's the word ratio in it, and what that ratio kind of means is that we have a fraction. So a rational equation is an equation involving rational expressions. So basically any equation involving our favorite friends' fractions, right? And what we're going to do to solve these rational equations is we are going to do this step of clearing fractions, okay? So I'm just going to do a bunch of examples for you. So let's look at this first example. 2x minus 1 all over 3 plus, whoops, sorry about that. Okay, sorry about that. 2x minus 1 all over 3 plus the rational expression x plus 1 over 2 equals 1. Whoops. Jeez, 1. I was getting a little bit ahead of myself thinking about how I'm going to clear the fractions here. All right, this all equals 1. My fault. So here's what we want to do to solve a rational equation like this. I want to get rid of the fractions. I know a lot of you don't like fractions. I don't understand why you don't like them. They like you. But what we want to do is we want to find what we call the LCD, right? My least common denominator. And once I find that LCD, I want to multiply both sides of the equation by that LCD. So again, remember why I'm picking that LCD. It is a number or an expression that each denominator divides into evenly. If I pick something that each denominator divides into evenly, then I'm going to get rid of these denominators, hence I get rid of the fractions. So if I look at this, what does this fraction need? This fraction needs a 3, right, to be able to divide out evenly. And then I'm going to look at this next fraction. This fraction needs a 2 for it to divide into the LCD evenly. So what is my LCD at 6? You probably can see that just by noticing, right, that you have a 3 and a 2. So I'm going to take that LCD 6 and I'm going to multiply both sides of the equation by 6. And I like to put this as 6 over 1. Over here, it's maybe not as important to put 6 over 1, but one mistake I often see students making is they try to take this 6 to the numerator and the denominator. I don't want to do that right now. I'm not getting a single fraction. I'm not combining the fractions on the left-hand side, so I actually am trying to clear fractions, so I don't want to multiply the top and the bottom by that number. I'm just going to multiply the entire expression by that number. I'm going to show you each step in this first one, and then after that, I'm going to kind of skip a couple steps. So let's take the 6 over 1 then, times this first fraction, right? Then I will have plus 6 over 1 times the second fraction, all over 2, equals 1 times 6, which we can do that. That's 6, right? That's easy. We can do that. All right, and now look at why you did this. Okay, people, this is why you did this. When I multiply this guy right here, 3 goes into 6. How many times? It goes in 2 times. So I'm left with 2 times 2x minus 1. People, if this number right down here does not divide this number evenly, you did something wrong with the LCD. Here, 2 goes into 6. How many times? 3 times. So I have plus 3 times the quantity, x plus 1 equals 6. Now look at how nice that is. We don't have a fraction. It's a pretty simple linear equation now to solve. So I'm just going to, take my 2 through, 4x minus 2, take my 3 through, 3x plus 3 equals 6. Simplify this a little bit. I get what? 7x, that's a 1. Take the 1 over, equals 5. So what does x equal? 5/7. Okay. And as long as I did, excuse me, as long as I did, all my math correct. That's a pretty big statement to say, but as long as I did all my math correct, then that will be my solution. Now, we have to be a little bit careful with rational expressions. The thing we have to worry about with rational expressions is anything that could make my denominator 0. So in this case, my denominators were just constants, so my denominator can't be 0. So I want to show you an example now where maybe that isn't so true. Dun, dun, dun. I really enjoy talking to myself when I make these videos. I wonder what that says. about me, but I'm all right with it. All right, let's do something like this. X squared over x minus 3 equals 9 over x minus 3. So again, I have a rational equation. I'm going to look at the denominators I have. What does this guy need, right, for the LCD? It needs an x minus 3. Now, I know you might be saying, Sarah, but I can cross multiply. You can. I'm just trying to do the same kind of method for every single one. I find sometimes students don't know when they can cross multiply and when they can't cross multiply. So I just want you to be kind of careful there. So my LCD is x minus 3. The other thing that I'm going to kind of put over here in my side work is because I have a denominator now that has a variable, is I am also going to state here that x cannot be 3, okay? So I'm going to state that x cannot be 3 because it can't be. No matter what I end up getting once I clear fractions, if one of my solutions says that x can be 3, I have to throw that out. That is not possible, okay? So now that I have kind of figured out what my LCD is, I've figured out what x cannot be, I'm ready to multiply by that LCD on both sides. Again, if you wanted to cross multiply in this case, you could. But what I like about doing it this way is I get rid of the fraction right away. So notice my x minus 3's cancel, right? So I don't have this extra step. If you cross multiply, you kind of have an extra step of you have an x minus 3 in there, and then you're going to have to, I don't know, combine like terms and all sorts of stuff when I can just multiply by that x minus 3 on both sides, okay? And so what do I get? I get x squared equals 9. I'm going to square root both sides, and I remember to bring in a plus or a minus, right? Whenever we bring in a square root that wasn't there originally, I bring in a plus or a minus. So my possible solutions are plus and minus 3. Well, because of the work I've done up here, I see right away that x cannot be a positive 3. So what is my only solution? X equals negative 3, okay? If we tried to plug in 3 in here, obviously we would get a 0 in the denominator, and that's a big, big no-no in mathematics. Let's do another one, because these are just a good time. I really like doing these. So how about 2 over 3x plus 6, okay, plus 1 over x squared minus 4 equals 4 over x minus 2. Okay, so to find my LCD, what I want to do first is I want to get everything in factored form. So I'm going to have 2 over, let's factor this 3x plus 6, at least everything in the denominator in factored form. X squared minus 4, that's a nice little difference of squares. That's x plus 2, x minus 2. And then on the right-hand side, can't really factor much, but I just get 4 over x minus 2. Okay, so now I'm ready to figure out what my LCD is going to be. So let's see what we got. So my LCD, let's look at this first denominator right here. So the 3 times x plus 2. So that's pretty easy to figure out. What is the 3 times x plus 2 need? Well, it needs a 3. It needs an x plus 2, right? What about this one over here? What does this need? It needs 1x plus 2. Well, I already have that x plus 2 taken care of, so I don't need to bring in another one. But it does need an x minus 2, so I need to bring in an x minus 2. And then over here on the right-hand side, what does this need? It needs 1x minus 2. I already have 1x minus 2 over here, so I don't need to add another one. Now, if this happened to be, which it's not, but if this had happened to be like x minus 2 quantity squared, we would need to bring in one more x minus 2 because I need to make sure that that denominator is going to cancel. All right, people, let's do this. So 3 times x plus 2, x minus 2. I should have given myself a little bit more room. X plus 2. And so this is where I'm going to skip a couple steps. I hope you'll be all right with that. When I take it to this first term, notice what's going to happen here. My 3 and my x plus 2 is going to cancel. What am I going to be left with? I'm going to be left with the x minus 2 times 2. So I'm left with 2 times x minus 2. Now remember, that just canceled for multiplying times that first term. I still have this whole thing that I'm multiplying to the second term, right? And so what's going to cancel in that case? The x plus 2 and the x minus 2 will cancel with the x plus 2 and the x minus 2 in my LCD. And what am I left with? 3 times 1, which is also known as 3 last time I checked. And then on this side, I actually can just go ahead and cancel them because I'm not distributing. It's only those two things being multiplied. So my x minus 2's cancel. I have 4 times 3, which is 12. And then I will multiply that by the x plus 2. Okay, so see how nice these LCDs are. you know, I have students that really don't want it clear fractions. I don't know what it is. I know I get that fractions can be complicated. I totally understand that. And I understand the hesitancy in dealing with them. But that's what's so great about this clearing fractions method is I multiply everything by the LCD. I mean, if you were going to get a common denominator and combine your fractions, you're getting that LCD anyway. Use it to your advantage to multiply it to both sides. All right, so let's finish this out. This I think you can do from here, but we'll just finish this out and we'll make sure, right, what can x, oh, I forgot to do it. Oh man, we forgot to state what x cannot be. So let's look here. What can x not be? X cannot be 2, right? X cannot be -2. And I think that's it. That 3 can never equal 2. So, wow, that was, 2 or -2. If I see a 2 or a -2, I'm throwing that sucker out. All right, so what do we get? We get 2x minus 1 equals 12x plus 24. So what do we get x to be? It looks like we get x to be a -25 over 10, I think. Yeah, which is also known as a -5/2, right? And is -5/2 equal to 2 or -2? I don't think so, unless something changed overnight. And I don't think that that's the same thing. You could always plug this in, of course, back into the original equation and make sure you get the correct answer. Okay. I hope that makes sense. I think that's kind of what your problems are going to look like. Again, if let's say my only answer was -2 or 2, and those were things that it couldn't be, then this equation just would have no solution, and that's a valid thing to happen. The equations can have no solutions. All right, let's talk about the last part of this section, and then we'll call it good. And let's talk about radical equations. They're totally rad. I know. I just have the best. I just have the best jokes. I can't help it. So radical equations is an equation in which because I had equations there, variables appear in one or more radicands. Radicans. Radicans is a big fancy word to just say the stuff underneath the either the square root, the cube root, the fifth root, the fourth root, whatever, underneath the root sign. So to be able to solve these, what we need something called the principle of powers, which sounds super cool and I feel like should be in like a superhero movie or something. The principle of powers. All right, and what the principle of powers says, if A equals B, then I can raise both sides to whatever exponent I want, right? And as long as I have equality here, then that equality will hold even when I raise both sides to whatever exponent I want. So you're going to kind of see where this is going, right? So for example, what if I had the square root of 3x plus 1, right, equals 4? Okay, so what I want to do here is my goal, so just like with the rational equations, my goal was to get rid of the fraction. In my radical equations, my goal is to get rid of the radical. So I want to get rid of any roots, okay? And to get rid of any roots, I'm going to use this principle of powers right here. The reason I'm going to use that is because what I know happens, this is a square root. So what's going to happen when I square that square root, right? When I square square root, it just goes away. So I get 3x plus 1 equals 16. See, these are pretty easy. 3x, then subtract 1 equals 15. So what does x equal? X equals 5. And you must check your answers with these guys, okay? The thing is, when we bring in that squared, what we've done is we've taken away that requirement for both sides of this equation to be positive. So just like when we solved equations of logarithmic equations and we got extraneous solutions, when you solve these radical equations, extraneous solutions are a possibility also. So in this case, I'm going to want to see you check. So I won't show every single check on this video because that would just get kind of boring. But I mean, not for me, maybe for you. So that's the square root of 15 plus 1, which is the square root of 16, which is 4, so that does work. So I don't have any extraneous solutions in that case. Okay, we could also have something like 4 minus 2 times maybe the cube root of x. I don't know, let's say equals, what do I want to do here? I have to think about this for a moment. I don't like having to think about things. So let's just do 8. All right. So I have 4 minus 2 times the cube root of x equals 8. So my goal again is to get my root by itself so that I can raise both sides to a power. Now, let me tell you something you can't do. I have a lot of people that want to do 4 minus 2 and make this 2. Don't you dare. Don't you dare do that. The reason we can't do that, your Aunt Sally would be so disappointed. So remember, Aunt Sally says that multiplication must happen before any addition and subtraction. This 2, my friends, are we friends? I don't know about that, maybe, is being multiplied by the cube root of x, right? So I actually can't take that 4 minus 2 because this 2 is being multiplied. So what I want to do is I want to get that cube root by itself. So I'm going to subtract 4 from both sides. So I get negative 2, right? Cube root of x equals 4. Then I don't want to cube it quite yet. I'm going to divide by the negative 2. So I get the cube root of x equals negative 2. Is that possible? Yeah, it sure is, because a cube root can equal a negative. That's all right. Now I'm going to use my principle of powers. I'm going to cube both sides. Okay, what happens when I cube a cube root? They undo each other, so I just get x. What happens when I cube a negative 2? We get negative 8, and we're done. And with the cube roots, you're not going to get extraneous solutions like you would with the square roots, but it's always a good idea to check your solutions. Okay? Okay. Let's do 2 more and then we'll call again. This will be like a record short video for me. All right, let's do 2 more examples. What if I had something like this? Now the rest of these are going to be square roots. 5 plus the square root of x plus 7 equals x. All right, so just like we did with the last one here, oh, I cleared it out, didn't I? With the last one, how I got that cube root by itself, my goal also with any of the radical equations, even if I have 2 radicals, which we'll do one like that, even if I have 2 radicals, what I want is I want to get at least one of the radicals by itself. If I can get at least one of the radicals by itself, then it's just going to be a little bit easier for me to solve. So I'm going to get the square root of x plus 7 by itself. So I'm going to subtract the 5. So I get square root of x plus 7 equals x minus 5. Now I'm ready to go with the principle of powers. I'm going to square both sides. Squaring the square root gives me x plus 7. X minus 5, quantity squared. Don't you dare make that x squared minus 25. Don't do it. People, you know, when you do that, a mathematician cries. Or at least a math teacher cries. Ugh. What does it mean to square something? It means to multiply it times itself, right? So x minus 5 times x minus 5. You can FOIL that out and you can see that we'll get x squared minus 10x plus 25. Now I have a quadratic. How do I solve a quadratic? I set it equal to 0. So I'm going to subtract x from both sides. Subtract 7 from both sides. So we get 0 equals x squared minus 11x plus 18. Oh, this one's lovely. All right, so what do we get? We get 0 equals, this factors nicely into x minus 2, x minus 9. All right, you guys, here are my possibilities. X can either equal 2 or x could be 9. And why am I writing these like this? Because I want to, first of all, and second of all, because I know I need to check these. Again, I have to watch out for extraneous solutions. I'm going to take this and I'm going to put this back into my original equation. You must put it into the original equation. Does this work? So 5 plus 2 plus 7 is 9. So I have 5 plus the square root of 9. Does that equal x, which is 2? Oh my goodness, you guys. It doesn't work. 5 plus 3, the last time I checked, clearly does not equal 2, right? So x minus 2 is not a solution. Let's check with 9. So if I check with 9 here, I get 5 plus 9 plus 7 is 16. Square root of 16. Does that equal x, which would be 9? This would be 5 plus 4. Sure enough, that equals 9. Yay! So we have one solution, and that is that x equals 9. Again, the problem is when you square this, you have forced both of these sides well, now they're positive, but what you've done when you squared it is you've taken away that requirement that both of them are positive. Okay, so you have to be careful with that. What it allows to happen is it allows either side to be negative, and you see if you plug in 2, you get a -3. So that's kind of what happens there and why that doesn't work. So the only solution is x equals 9. So again, you must check your solutions to make sure you don't have anything that's extraneous. All right, one more. Told you this was going to be pretty fast. We're only at 20 minutes. Wow, except this one's a bit of a doozy. So we'll see. It'll be fine. Let's do a square root of x minus 3 times the square root of x plus 5 equals 4. So my first step, just like I said before, is I want to get one of these square roots by itself. So I'm just going to move this one over. There's no reason I'm choosing that one. It's just because it's the one on the right. That is literally the only reason I'm doing it. So I have 4 minus root x plus 5. Again, why am I doing that? Because if I tried to square this right now, remember I can't square each term because this is addition. I would have to FOIL that whole sucker out. Now, granted, I'm going to have to FOIL this whole sucker out right here, and it's going to be a little bit gross, but at least I have one term that doesn't have a square root in it. Okay, so let's square both sides. And I am going to kind of show you the steps on this one. When I square that square root, we just get x minus 3. Here, I'm going to get 4 minus, and I'm going to write this out. As you get better at these, you'll probably get to where you don't maybe have to, write this out explicitly every time. But until you get to that point, go ahead and write it out. Don't skip steps. That's where I see my students get confused, is when they skip steps. All right, let's FOIL this sucker. 4 times 4, I know that is 16. Right? If I do outside, 4 times the square root of x minus 5 is negative. Square root of x minus 5 is just a -4 root x plus 5. Same thing here. I just get a -4. That makes sense because I'm squaring something, right? So I get twice the out terms and the inner terms there. And then last here, notice what happens. I have a negative times a negative, so that's going to give me a positive. And then when I take the square roots, basically when I do last, I'm getting the square root of x plus 5 squared, right? Because I have 2 of them. So the square roots go away, and I'm just left with x plus 5. Oh, I don't know. This probably doesn't surprise you, but I really like doing these. So let's combine some stuff here. The 6 and the 5 I can put together. That gives me 21. Whoops. There we go. That's a little bit better. The x I'm just going to kind of move up here because I think it'll be easier. And then here I have a -4 root x plus 5 minus 4 root x plus 5. So how many root x plus 5s do I have? I have a -8. I can combine those as like terms. Root x plus 5. Okay, you guys, notice I still have a square root in my equation. So I am going to have to square one more time. I have to call for the principle of powers one more time. Okay, so I'm going to get that guy by itself. Let's subtract 21 from both sides, right? Oh, and this one we got lucky. The x's cancel. So I get a -24, okay, equals a -8. Whoops. I don't know what happened there. Okay, sorry about that. We had some technical issues, so that probably looks weird. It just jumped around. Okay, anyway, I'm left with, as I was saying, I believe before, I'm left with a -8 times the square root of x plus 5, okay? Right now, so you can square right now if you would like, but I'm going to give you that hint that if whatever this number is in front of the root, if it goes into whatever is on the left-hand side, even if there's more than one term on the left-hand side, go ahead and take it over. If it does not go into each term on the left-hand side, square first, and then take that, then mess with it. But look at this is pretty nice. I get 3 equals the square root of x plus 5. This is going to be pretty simple to solve. I'm just going to square both sides. So we get 9 equals x plus 5. Subtract the 5, and we get x equals 4. And then, of course, we need to check. So let's check and make sure we didn't do all that work for nothing. So what am I going to check into? I'm going to check into this equation right here, right? My original equation. 4 minus 3 is 1, so does the square root of 1 plus 4 plus 5 is 9, the square root of 9, does that equal 4? Oh, praise the math gods, it does, and we're very happy about that, so we draw a little smiley face. and we're done. These can sometimes get a little more complicated. Look at the fun sheet. There's some on the fun sheet that are a little more complicated. Look at those solutions. And of course, let me know if you have any questions.